So you're most welcome to our very last Researchers Desk seminar of the year. And to finalize the year, we have two of our very own stars then, Kevin Noone and Alasdair Skelton, who will talk about the challenge of the rejection of the Anthropocene. And so with this very short introduction, Alasdair and Kevin, please take it away.
Thank you very much indeed, Glenn. And I just confirm for me that you can see my slides.
Yes, fine.
So it's a pleasure to speak for Researcher's Desk. I'm very fond of Researcher's Desk. And what we're gonna do today is that Kevin and I are going to challenge the rejection of the Anthropocene. I'm going to begin by defining some terminology. I'm going to explain what the Anthropocene is, and I'm going to explain as a period in geological time. I'm going to explain what geological time is. And then I'm going to look at a little bit of a comparison of how other geological times have been defined. And then I'm going to hand over to Kevin and we'll see, he'll take it from there when I tell you what the geologists actually decided. So I'll just get started here. You're looking at Siccar Point, by the way. This is a fundamentally important place for geologists. You're looking at one group of rocks, red-colored ones, overlying older rocks that are grey. Between them is a gap in time of 100 million years. Everything that we're going to talk about when we focus in on this is happening within a shorter time span than you can put your finger on standing on the rocks on the northeast shore of Scotland. So let me dive right in. So what I'm going to do first is I'm going to explain some terminology, and that is what do we actually mean by geological time, and what are the terms we use to describe it. And I'll begin a bit scientifically, and then I'll try and explain a little bit more what I mean. So when we talk about geological time, we divide the 4.6 billion years of Earth's history into four eons. Now I'll try and give a perspective of 4.6 billion years in a minute, but I'm not going to pretend that I understand it myself. So those eons, we've divided the Earth's history into four of them. We then, if we take the most recent eon called the Phanerozoic, we divide that into eras. Those are called the Cenozoic, Mesozoic, and Paleozoic, and they take us back 541 million years. And we also divide the Phanerozoic up into periods. And those periods are often the names we're most familiar with. Most of us have heard the name Jurassic, and if we haven't, there's a great movie we should be watching at some point. I belong to the group of people who did cry at the beauty of the scene of the dinosaurs grazing on this island. But the geological periods is what we usually tend to think about with geology. Now, the period we live in is actually called the Quaternary, and that is actually so short that I can't even represent it on this figure. So what we're going to do now is we're going to expand the Cenozoic into the epochs. Now, the Cenozoic, which is made up of two periods, the Neogene and the Paleogene, is also then divided up into six epochs. And we're going to kind of focus on that because as we're going to see, the proposal for the Anthropocene is that it would actually be an epoch. The epoch that we live in if the Anthropocene does not exist is the Holocene. If the Anthropocene does exist, it's the Anthropocene. The Holocene is so short, 11,700 years compared to 66 million years of the Cenozoic, that I cannot represent it on this figure. As to the Anthropocene, we'll see even shorter. Okay, right, geological time. It's fascinating and it's really difficult to get a grip on. So let's take those 4.6 billion years and we're going to we're going to try and use a metaphor. We're going to imagine if those 4.6 billion years were 24 hours, let's just walk through geological time and see the significant changes that have happened. Okay. This is going to be quite brief. If you've heard my walk through geological time before, this will not be that one. This is a very abridged version because I want to give Kevin at least 10 seconds to speak. So Geological time starts with the Hadean Eon. That would take us up to 2:52 in the morning of this geological day. This is not a very pleasant time. There are neither continents nor oceans. The Earth is covered by a magma ocean and it's being bombarded by um, asteroids from outer space because there's almost no atmosphere to burn them up. This is not a good time. So if you manage to work out how to time travel, don't travel back to the Hadean. It will be the last thing you do. Moving forward, we come into the Archean. And the Archean is a wonderful time. It takes us up to 10:48 in the morning. And it's a time that is characterized by a very different world with lots of tiny little continents, probably not much bigger than Gotland. And they're moving around the Earth relatively quickly. And they're moving so quickly because the interior of the Earth is hotter. The Earth is slowly cooling down. Moving on, we come into the Proterozoic eon. Now, this also is a wonderfully exciting eon that takes us most of the way through the day until 9 minutes past 9 in the evening. The Proterozoic eon is bracketed by huge climate change events that we call snowball Earth episodes. Both near its start and close to its finish, Earth appears to freeze over entirely. Why that happens is another story, which I'm not going to tell you right now. Um, when we come to the final eon, we divide that up into eras because we're getting closer to our own time and we know more about it. Starting with the Paleozoic era, that's going to take us to 1040 in the evening. This is the time when we start seeing complex life on Earth. Begins in the sea and then moves on to the land. Plants evolved during the Paleozoic. All those fossils that you're not going to admit to having collected, they probably were from the Paleozoic era because they're probably from places like Gotland. Moving forward, we come to the Mesozoic era. This takes us until 2339, so 21 minutes to midnight. This is the era that we know and love. It is the era of dinosaurs. It's also the era that most of the coal that we burn when we're burning fossil fuels comes from, which is like a bad idea because it's very, very old uh, carbon dioxide from the ancient atmospheres that we're putting in our own, and it's just too much of it. That's also another story which I'm not going to tell you now. But the era of dinosaurs is also the era of Pangea, which when all the continents were joined together. And it takes us up to the fifth mass extinction. At 21 minutes to midnight, Earth is hit by a meteor from outer space, and that is the cause of the extinction of the dinosaurs. It's also the cause of the extinction of a lot more species, mass extinction being defined as 75% of species on Earth go extinct. Um, After that mass extinction, we come into the Cenozoic era, which takes us up to midnight. And this is an era dominated by a trend of global cooling, which is probably largely related to the rise of the Himalaya. And there's a whole bunch of reasons why. That's also part of another story. That takes us up to midnight, and where we enter the sixth mass extinction. And I have a footnote here. This particular mass extinction can still be avoided, and that's one of the reasons we have researchers' desks. We're working on not having a sixth mass extinction, at least now. Geologically, one will happen inevitably in the future, but we don't need to be the cause. This is everything that we're going to talk about the Anthropocene is within a millisecond of midnight. So for the story we're telling, it's pretty well exactly on midnight. This is a time where one species evolves, develops an odd relationship with nature, where it sees nature as a resource and starts manipulating the planet in a massive way, a species that becomes a geological actor, meaning that it shapes the geological fabric of which we depend on for our very survival. And that brings us into the Anthropocene. And the Anthropocene, to give you a little bit of terminology there, this is a proposal. The Anthropocene, and it's a proposal of a new epoch. It would be an epoch. It would not be a period. It would not be an era. it would not be an eon, although the first usage of the word Anthropocene was actually linked to the word era. So it would be a new geological epoch. It would be defined by a golden spike. Now, this is a marvelous thing. A golden spike is literally a gold-colored, it's not made of gold, but a gold-colored spike that some geologist goes and hammers into a rock face somewhere and says, there, that's where it starts. So it's a very, very tangible thing. So the Anthropocene as an epoch would be, we would actually need to hammer a spike into some piece of sediment or rock somewhere, and Kevin's going to tell you more about that. And it will coincide with the Great Acceleration. Those of you who are more engaged in the social sciences and the humanities know what that is. But just to give very, very briefly, this is basically from an inflection point in the 1950s, where everything starts happening faster. Population rises faster, economy goes completely out of control, fossil fuel burning goes mad, carbon dioxide concentration in the atmosphere starts rising rapidly, and we can even see it in isotopes that geologists could use in 100 million years. We'll see that record in sedimentology. So the Great Accelerate, and the primary marker, that's what would be define where the Anthropocene starts, is actually not to do with any of that. It's to define an epoch, you need to have something you can find over the entire world. Well, one thing that did leave a fingerprint and also coincides with the start of the Great Acceleration were the radionuclides spread by the bomb tests from the 50s. So the proposal would be that if there is an Anthropocene epoch, we would mark the start of it by the radioactive nuclides that we will find in sediments for hundreds of million years to come, marking that particular time. Okay. So how does the case for the Anthropocene compare with the case for previous epochs? Well, let's take a look. Now, just to remind you, we're now going to be talking about epochs, and those are divisions of the Cenozoic era, which is in itself divided up into these two periods, the Neogene and the Paleogene. We're going to focus entirely on that 66 million year period of time that is from the fifth mass extinction to the mass extinction we're presently trying to avoid. So that's extinction of dinosaurs, meteorites, up into the present day. So let's take a look at it. So that's divided up into a bunch of epochs, each of which has a very poetic name, none of which are particularly easy to relate to. What I'm going to do is I'm going to show you the scientific definition of what, and then I'm going to show you what it actually means. The scientific definition will always be followed by a reference. So the Eocene, starting at 56 million years ago, the start of it is defined by what geologists call a hyperthermal. That's a transient, means it's short-lived for geologists, global warming event of 6 degrees. The onset rapidly, that means, and for geologists rapidly, it took 20,000 years to start, and it lasted for, as I say, transient, a short period of time, just 200,000 years. And it may have been associated with 2 doublings of carbon dioxide levels in the atmosphere. So what does that actually mean? Well, to see what it means, let's look at a sediment core from the South Atlantic Ocean. If we look at that sediment core, we see that the sediment pulled up from the seafloor is white. The reason it's white is it's full of lots of living things that are white, except for one little gap of 200,000 years where there are no white things. Those white things are little fossils called foraminifera. In addition of a vast amount of carbon to the oceans during that time meant that that the deep living ones dissolved, and there's 200,000 years with no life in it. That's actually what that boundary means. Moving on, moving on now to compare that with the Anthropocene. The Anthropocene, and I'm going to call it Anthropocene warming, is happening 50 to 80 times faster than it happened at the onset of that hyperthermal, based on 6 degrees over 20,000 years. Also, a full recovery from Anthropocene warming will take as long as from the hyperthermal, according to a bunch of scholars in a paper published by Archer and colleagues. 200,000 years will be the recovery time from Anthropocene warming. And at its current rate, Anthropocene warming will reach 6 degrees within 2 to 3 centuries. All right, let's now move on to the Oligocene. And the Oligocene is the end of a major climatic shift from greenhouse to icehouse conditions. I'll explain what that means in a minute. with global cooling of about 2.5 degrees in 500,000 years, coupled with the onset of Antarctic glaciation. This is a very important time in Earth history. This is roughly what the world looked like. And as we see, we're starting to get glaciers on Antarctica. This is two stable climate states. One stable climate state is a greenhouse, no ice, no snow, and the other is with ice and with snow. The switch from greenhouse to icehouse means that's what happened. This is a major, major climatic event. All right, so let's compare it with what's going on now. Anthropocene warming is happening 4,000 times faster than cooling did during the switchover into the Oligocene. The average rate of change of carbon dioxide levels in the atmosphere, which is what's causing Anthropocene warming, is 50,000 times faster now than during the Eocene to Oligocene transition. All right, let's try the Miocene then. This geologists refer to as a transient. Now remember, geologists have a very weird idea of transient. That's 400,000 years. Long global cooling event, about 2 degrees. And it's coupled with a near doubling of the size of the Antarctic ice sheet and a 150 part per million fall of atmospheric CO2 levels. So what does that mean? This is when Antarctica began to look like it does today, covered in ice, covered in glaciers. Let's compare it with the Anthropocene. Well, Anthropocene warming is also associated presently with a 150 part per million change of atmospheric CO2 levels. So the change is exactly the same. Unfortunately, Anthropocene warming is that number is increasing, so it will soon be more. And a full recovery, as I've said before, from the Anthropocene warming will also take hundreds of thousands of years. So these are fairly comparable events. Well, we're almost done. We're moving on to the Pliocene. The Pliocene is an interesting one. You see, this is characterized by a return of open marine conditions to the Mediterranean Sea after its desiccation during the Messinian salinity crisis. So what does that mean? That means the Mediterranean had actually dried up due to a bunch of tectonic reasons that we're not going to go into. And the start of the Pliocene is marked by when the Mediterranean flooded again. So how does that compare with the Anthropocene? Well, the Anthropocene is a global event. This, unlike the return of open marine conditions in the Mediterranean, which actually happened in the Mediterranean, hence the name. One of the criteria that we kind of like to have for an epoch is that it should be global. But nevertheless, the Pliocene is an epoch. And if we move on now to the Pleistocene, okay, defines the start of the Pliocene? This is technically speaking, this is the midpoint of a 300,000 year interval during which Northern Hemisphere glaciation intensified, with a switchover from local glaciers and ice caps to major ice sheets in Greenland, North America, and Scandinavia. In other words, this is when the Arctic Ocean began freezing over, Greenland started getting covered in ice. This was the beginning of what we call the Ice Age, not to be confused with an ice house. An ice house just means there's so much snow and ice somewhere. In an Ice Age, those ice sheets are advancing and retreating. The only thing is, the Pliocene was not defined as the start of that. It was defined somewhere in the middle of the intensification of that. So it wasn't actually the major climatic event at all. So if we compare with the Anthropocene actually is we're going to argue in a second, has a much clearer climatic signal, which I'm about to show you, than, I quote, the midpoint of a 300,000 year interval during which Northern Hemisphere glaciation intensified. So we've only got one left, the Holocene, and the Holocene is defined as the start of the warm period that began with the end of the last glacial period. Well, what do we call warm periods during an ice age? We call them interglacials. So during an ice age, we flip between glacials and interglacials currently it's roughly every 100,000 years. So let's look at the past interglacials and let's ask ourselves, is the Holocene actually different from any of them? Is there something that makes it special and unique, that it somehow should be an epoch when none of the others are? Well, this is what we call it. This is the temperature anomaly for each of the past 5 interglacials. And you see, they overlap one another, so you can't really distinguish one from the other. They're a bit colder, a bit warmer, whatever. So is the Holocene really so distinct? Well, there's the Holocene. It overlaps with them all. So it's pretty hard to distinguish it from any of the other interglacials. But nevertheless, the Holocene has been given epoch status. None of the others have. So, okay, but what about the Anthropocene then? So let's compare the Anthropocene temperature anomaly, just meaning how different a temperature is from normal, where normal in this case is defined as before we started messing up with the climate. So let's just see, is the Anthropocene temperature overlap the Holocene? And it did, but it doesn't anymore, and it hasn't done since 2013. So since 2013, the temperature anomaly for the Holocene for the Anthropocene is actually, if there is an Anthropocene, is actually different from the Holocene, meaning unlike the Holocene or the Pleistocene, there is a unique climate signature. So with all of that data and having defined 6 previous epochs, what did those geologists actually decide? Well, you can read it in Nature. Geologists reject the Anthropocene as Earth's new epoch after 15 years of debate. So the geologists said no. Okay, Kevin, why did they say no? I think it's time that I leave and we let Kevin in.
Thanks so much, Alasdair. Um, I'll share my screen, and what I'll be talking about, Alasdair's given us this really wonderful description of how geologists think about epochs and periods and eras and whatnot. What I'll be talking about is not so much the geology or the science, but the process. So Alasdair mentioned that despite all of this evidence that we have, scientific evidence, that we have for the Anthropocene being at least as definable as an epoch as many of the other ones in this Kenozoic period, it wasn't. So how did that happen? So that's what I'll be talking about today. What we'll do is 3 things. I'll talk to you a little bit about the approval process. We'll talk about conjectures and refutations. I hope somebody recognizes that's the title of a book. But regardless, we'll talk about conjectures and refutations about the idea of an Anthropocene. And then I'll end with talking about governance and how, whether or not this process was carried out in a reputable governance way. So let's dive in. This is the holy grail for Anthropocene stratigraphy. This comes from a personal communication by the former head of the Anthropocene Working Group, Jan Zalasiewicz. So what you're looking for, if you wanted to find an epoch, an Anthropocene epoch, is a material unit of strata that can be identified by distinctive and unique time-significant evidence, such as fossils and or physical or chemical properties rather, and in particular has markers that can help recognize the boundary between it and Holocene deposits. So that's what you're looking for if you want to define a new Anthropocene epoch. Did you find it or not? So here's the process through which a new epoch can be defined. Now, there's about as many layers in this process as there are layers in the core from the Crawford Lake sediment, as you see to the right here. So we'll walk through them, starting from the bottom, going to the top. So if you want to define a new epoch, first you have to have a working group that goes and gathers evidence and tries to figure out what, if there is evidence for an epoch and what that evidence is and what it should be. So that's the working group at the bottom. In the middle, there's a chart that comes from a publication by the president of the IAGS. I'll get to what that means in a second. From 2016, saying this is what you need to do if you want to define the Anthropocene as a new epoch. So the Anthropocene Working Group, that was started in 2009. We'll come back to a timeline in the next slide. So that's the bunch that goes and looks for evidence for a new epoch. Once they've gathered enough evidence, and once that group has a super majority, that is 60% or more of the group saying, yes, we want to recommend a new epoch, that recommendation goes to a subcommission. And that's a subcommission on quaternary stratigraphy. Okay, Alasdair had mentioned the quaternary before. I don't even remember if that's a period, epoch, whatever the quaternary is, Alasdair. You have to remind me.
It's a period.
The period, thank you. So that goes to a subcommittee. If 60% of that subcommittee says, yes, we support this proposal, then that gets kicked upstairs to the ICS Bureau, which is the ICS executive. and all subcommission chairs. That's the International Commission on Stratigraphy. That's what ICS is. And if 60% of that bunch thinks that this is a good proposal, then it gets kicked upstairs, or even farther upstairs, to the IUGS, the International Union of Geological Sciences Executive Committee, who then votes on ratification. So you can see there are several steps in here in this process which require a supermajority at each step for a new epoch to be defined. Okay, so that's, in theory, how things work. So what's the timeline for the Anthropocene epoch? And for me, as an atmospheric scientist, Alasdair and I did a wonderful thing, I think, this last summer. We had a course where we looked at processes that happen that are basically the same processes, but happen in the atmosphere, really rapid timescales, and happen in geological terms in rocks and really slow timescales. For me, this is a long timescale. But for a geologist, this is like a blink of an eye. So the Anthropocene Working Group was formed in 2009. They trundled off and started to work, and they worked for a long time. They worked for a decade before they actually came up with a proposal. And during this period, there were a number of what I'll call conjectures and refutations. So some members of the Anthropocene Working Group were opposed to the idea of an Anthropocene as an epoch. And they published papers saying, okay, here's some reasons, here's some arguments why we don't think this should be an epoch. And those papers were responded to. So there was a very scientific debate, a scientific conversation going on in the literature about the pros and cons of an Anthropocene as an epoch. We get to 2019, at which point the Anthropocene Working Group decided they're going to vote on whether to recommend the Anthropocene as an epoch or not. And there were 29 votes to approve and 4 votes to reject. So you can see that we have indeed a supermajority of the Anthropocene Working Group members said, yes, we find that there is sufficient scientific evidence that the Anthropocene should be called an epoch. But then they had to go and find Alasdair's golden spike. They had to find a couple of places or a particular place on the planet where you could find a record that shows there is a significant change in geological parameters between the Holocene and the Anthropocene. And there's where some of the controversy started and some of the tension started, is because that process was ongoing. But the organization at the top, the IUGS, said, hey, hurry up, guys, we're getting tired of waiting for you, in essence. So they were pressured into submitting a proposal, which they did at the end of 2023. I'll show you a little bit more about the details about that proposal in a second. And then early in 2024, that proposal was rejected on March 26th. Okay, so that happened pretty rapidly. The rejection, the time between the actual proposal and the rejection was relatively rapid. So let's take a slightly deeper dive into this process and see what's going on. So throwing down the gauntlet, what I want to do here is to show, okay, so between the time of the formation of the Anthropocene Working Group, 2009, what happened? What are some of the milestones along that pathway? One of those milestones was a special issue. This is an entire issue of a journal, the Geological Society Special Publications, number 395. A say this 3 times rapidly, stratigraphical basis for the Anthropocene. And one of the papers in that was written by Stanley Finney, who is the president of the IUGS, and he said, look, if you want to have this ratified as an epoch, there are some fundamental issues that must be addressed by the task group. And he wrote a paper about them, saying what they were. And the task group, the working group, read that paper, and they started trying to address the points that Finney made. Let me present just a couple of arguments, counter-arguments and arguments against the Anthropocene. So here's one of them. What this chart does is it shows you the last 1,000,000 years But that last million years is sort of kind of on a logarithmic time scale. Okay. So the leftmost column is about a million years ago. The one next to that goes to about 100,000 years. The one next to that's 10,000 years. So we're taking Alasdair's geological time and sort of squishing it unevenly across that horizontal axis. And basically what this chart is trying to argue is that we humans have had influences on our planet for much longer than since 1950, much longer than since the Great Acceleration happened, right? And towards the bottom of this, you'll see a historical timeline where we have urbanization starting maybe 10,000 years ago when we started settling down instead of being hunters and gatherers. We had global trade and colonialism for perhaps the last 800,000 or 800 years. We've had fossil fuels in a big way for the last 100 years or so. We've had agriculture for maybe 10,000 years. And we figured fire out a couple 100,000 years ago, right? So the arguments that are made by the people on the Anthropocene Working Group and others in the IUGS that the Anthropocene should not be an epoch were made using the arguments that, look, humans have had an effect on the planet for quite a while. And that's what this chart shows. But what's on the vertical axis on this chart? What are the magnitude of these effects that are shown on the horizontal logarithmic axis? And that's one of the counter arguments that the other members of the Anthropocene Working Group made, was that, okay, yes, we humans have been around for a while. As a species, we've been around from between 200 to 300,000 years, depending on what evidence you want to look at. But our planetary scale effects are very, very recent. And that's what you can see on this chart, depicted on this chart. So let's just look at the very topmost of those, the blue one, which is the temperature. And this comes from a record of cores, sediment cores that have been taken all around the world. And you can see that when the last glaciation was at its very coldest, global temperature was about 7 degrees cooler than it was pre-industrial, right? And then it cooled up, and the Holocene started 10,700 years ago, according to the definition. And we can see that was a period of warming at that particular point. Then we had a stable-ish temperature through the Holocene period, and then ding, temperature goes up extremely rapidly, like Alasdair told us about previously. And that's being driven by the increase in carbon dioxide, which you see in red, which also increased between the last glacial period to the Holocene, and now is increasing extremely rapidly. Methane, nitrous oxide, other gases too. So the reply to the argument that humans have been around and been affecting the planet for a long time is one that, yes, that is a true statement, but the effects of us humans haven't been a planetary scale until very recently, until the Great Acceleration. Okay, so we've got a whole lot of scientific evidence that says that this particular change should be an epoch. I find this particular paper really telling in terms of whether or not a scientific process had been followed throughout this whole thing. Now, the paper I'm referring to is given down at the bottom by Finney and Edwards. It's published in 2016. And here on the left, the text on the left, are just a couple of quotes from that paper. Now, keep in mind, the Anthropocene did not vote on having a proposal, on creating a proposal until 2019, and they didn't submit a proposal until 2023. This is 2016, and here we have the president of the IUGS saying it's a political action that's required to meet the ultimate goals of ameliorating human impact, which raises the question of the ICS making a political statement. So already before there was even a proposal to consider, the president of the IUGS was wondering whether or not calling this new epoch an epoch would be making a political statement. Now, for me as an outsider, that in itself is a political statement, because you should be waiting for the scientific evidence, which hadn't been presented yet. So making this statement in advance of having that scientific evidence is in itself a political statement. All right, so keep that in mind. That sort of frames, if you will, some of this process. So here's what happened in 2019. 29 of 33 voting members of the Anthropocene Working Group voted yes to two questions. One question would be, should the Anthropocene be treated as a formal chronostratigraphic unit defined by a GSSP? And the second question, should the primary guide for the base of the Anthropocene be one of the stratigraphic signals around the mid-20th century in the Common Era? Okay, so Anthropocene Working Group said yes to that. And here's what they submitted. They submitted a very detailed explanation of what signals, what parameters you can observe. And this particular golden spike was proposed to come from a place called Crawford Lake in Canada. And in the center there, you can see the sediment core or a sediment core from Crawford Lake with 1950, which is the proposed base of the Anthropocene shown in that core. And you can go and find in the references to the right in this image a very, very detailed scientific explanation of why. And it's not just this one location. There were locations all around the globe that showed very similar signals and similar timing, but this turned out to be the one that looked the best, according to this group. So that was 31st of October, Halloween, my favorite day of the year, 2023. Here we have no from the International Commission on Stratigraphy. And this was what you see on the screen is basically the rationale that was presented by that group for rejecting the Anthropocene. Huh. Okay, so how did that happen? There's been criticism of this process, right? So in a paper published 2014 by Stanley Finney, again, the president of the IUGS, he published a very clear procedure for the approval of new epochs, right? And talked about how that organization actually approves these stratigraphic definitions. Among the things that were included in that paper as prerequisites for the process of establishing a new epoch, two of them were an extended opportunity for discussion once a proposal has been made, and the opportunity to raise and address questions once that proposal has been made. Now, keep in mind, let's back up a slide. Whoops, nope, giving it away. That was 31st October 2023, and the rejection happened in March of 2024. Okay, so there's been discussion whether that is extended amount of time for opportunity, discussions, and raising and addressing questions or not, given how long the process had taken since the formation of the Anthropocene Working Group. There were also disagreements about procedure. So the chair of the Anthropocene Working Group and other members of the Anthropocene Working Group maintained that there wasn't any extended opportunity for discussion and responses to questions. In fact, there was only one set of questions that were submitted at that point. The other questions had been raised in papers in that period between 2009 and 2023. The vote was in closed session, the vote to reject the Anthropocene, and it was against the wishes of the Anthropocene Working Group chair and the vice chair. So they didn't want the vote to happen, and yet it did. There was also a question about the eligibility of voters. So anybody familiar with organizations know that in many cases, if you have a board or some sort of a committee in your organization, they have term limits. The members of that committee or board have term limits. That's the case for the IUGS as well. And in this particular case, a large number of voting members of the committee that rejected the Anthropocene proposal actually were past their term limits. So from an organizational point of view, if you have term limits, then you should respect the term limits, which didn't happen in this particular case. The final nail in the coffin of wondering whether or not this particular process happened properly or not was that it was appealed to the Geoethics Committee of the International Union on Geological Sciences. The recommendations of that committee were submitted only to the IOGS president, and he released them only to members of the SQS, that's the Quaternity Subcommission on Quaternity Stratigraphy, thank you, after the vote. And that is still not public. And while Alasdair and I got a copy of a chapter for a book on this subject, the author of that chapter asked us not to refer to that, so I will respect that. That is still not public, but what we can say is the results of that will be very, very interesting to see at this point in terms of whether or not a process was carried out properly or not. So Alasdair and I just assigned grades to some of our students in a course that we ran. If I were to grade this, now I do have some experience with organizational processes, having some previous jobs where I was running organizations like that. My own grade would be here. I think looking at this process as an outside observer, it was not carried on in a professional way. So I'll stop there, Alasdair, and we can perhaps have discussions on potential motivations for why this process went to hell in a handbasket. But that would be speculation, so we'll stop there.